Hello, and welcome to Becker Breaks It Down. So let's talk about trig functions of any angle. In the previous episode, we focused only on sine and cosine. But as you know, there's tangent, okay? But there are also three other trig functions, okay? And those three are going to be cosecant, secant, and cotangent. And so what I want us to be able to do is I want us to be able to find exact values for any of our 6 trig functions, given either a right triangle, a point on the terminal side of an angle, or even another trig ratio. Okay, but cosecant, secant, and cotangent. So check this out. It's like we all know sine, cosine, tangent, the big three when it comes to trig functions. They have buttons on calculators. Yeah, they really can tell us a lot about some measurements, angles and stuff. So sine, we always think of sine as the SOH, the SO of SOHCAHTOA. Sine is the opposite over hypotenuse. Cosine, the adjacent over the hypotenuse, and tangent, the opposite over adjacent. So what about these other three? Okay, let's check this out. So we got cosecant is the hypotenuse over the opposite. They took sine and they flipped it, because sine is the opposite over the hypotenuse, and cosecant is the hypotenuse over the opposite. So it's just the reciprocal. So does that hold for our other functions? So secant is the ratio of the hypotenuse over the adjacent. Yeah, it's just the reciprocal cosine. And cotangent follows a similar pattern. Cotangent is the adjacent over the opposite. Hey, that's just the reciprocal of tangent. Right? It's the big three. Definitely know the big three, sine, cosine, and tangent, and their like ratio rules. Okay. SOHCAHTOA helps us with that. And then just remember the reciprocal, like buddy system. So sine flip, you get cosecant. Cosine flip it, you get secant. Tangent flip it, you get cotangent. Flip to find the recip. So this problem, we've done problems like this before, except before we weren't finding the values of all 6 trig functions. We were only finding like maybe 2 or 3 of them, sine, cosine, and tangent. But here, let's find all 3, or I'm sorry, all 6. So look at what you've been given. You've been given a right triangle. Okay. You know in the right triangle that the hypotenuse is 3. You also know the opposite theta. You know that side, so that's the opposite. So what you're missing is you're missing the adjacent side, but that's okay because of Pythagorean theorem. So we do the Pythagorean theorem, and we end up with that missing side b is 2 root 2. So now we're ready to find the exact values of all 6 ratios. And that's like really easy to do, okay? Because you find sine, so sine is the opposite over hypotenuse, so you get 1/3, and then you flip it, and when you flip it, you get cosecant. So cosecant is 3/1, or even better, 3. So let's do that with the remaining trig functions, okay? So if we do that with cosine, we get 2 root 2 over 3, and then we flip it, and we get that secant is 3/2 root 2. Tangent is opposite over adjacent, so tangent is 1/2 root 2. We flip it, we get cotangent, which is 2 root 2, okay? So these are like the initial ratios, right? I do want us to simplify these, okay? So if it is possible to simplify the expression, we should. So look at any outside fractions. Can they be reduced? And then also remember, we can't go leaving square roots in the denominator. So we have to rationalize the denominator to get rid of it. So whenever you see, like with secant here, You have the square root of 2 on the bottom, can't be there, and it's all his fault. So what we do is we just simply multiply it by the square root of 2. But we have to do that on top because we got to keep things fair and balanced. So on top, what we end up with is 3 root 2. On the bottom, we're going to end up with 4. And so remember, we're getting 4 because like the square root of 2 times the square root of 2 is 2. And 2 times 2 is 4. Okay. So I have to do the same thing with tangent. Can't go leaving that square root of 2 on the bottom. So I have to multiply the square root of 2 on top and the bottom. So on top, I get 1 root 2. And on the bottom, I end up with 4. Okay. So simplifying is probably like the hard part, if there's anything hard. But getting the initial 6 ratios is really easy. Okay. So let's check out like another scenario. And you've seen such a problem before. It's to sketch the reference triangle in the proper quadrant. So we're given that the point 4, -6 is on the terminal side. So we have to be like, what quadrant is that? What quadrant is x positive and y negative? Yeah, that'd be quadrant 4. So we're going to draw a reference triangle in quadrant 4. We're going to label the sides accordingly. So we know the x side is 4. We know the y side is -6. And well, we're missing the hypotenuse. If only there was a way we could find it. Oh yeah, Pythagorean theorem. Okay, and so we end up with the hypotenuse is 2 root 13. Remember, the hypotenuse is always going to be positive. So once you get all 3 sides in your reference triangle, you pause, you check your signs, S, I, G, and S. All right, and everything looks good because in quadrant 4, X is positive, Y is negative, and R is always positive. And so now we're ready to go about finding our 6 trig functions. So the very first thing that we could do is we could just write out all the initial ratios and worry about simplifying them in the next step. So sine, as we know, is opposite over hypotenuse. So that'd be like -6 over 2 root 13. And then we simply flip to find the recip. So cosecant would be 2 root 13 over -6. So I'm just going to go about finding the initial ratios for all of these, and then I'll worry about simplifying them. Okay, boom. Okay, so you may have noticed when we wrote down sine was like -6 over 2 root 13 is that the -6 and the 2, we can reduce that. And so if I do that, I'll end up with -3 over the square root of 13. And then when I flip that, right, then I get the cosecant equivalent of negative square root of 13 over 3. Going back to sine though, like I can't go leaving the square root of 13 on the bottom. So I do need to multiply the top and the bottom by the square root of 13. So I'm going to get like -3 root 13 over 13 is my final answer for sine. So notice for cosine, I originally had 4 over 2 root 13. The 4 and the 2 can cancel out, giving me 2 over the square root of 13. And then I have to rationalize that because I can't go leaving the square root of 13 on the bottom. So I end up with 2 root 13 over 13. Okay, so simplifying, that's the worst part of these problems is simplifying the initial ratio. Okay, but finding the initial ratio isn't really that difficult at all because we already know the big 3, sine, cosine, and tangent. We are comfortable with those. We've worked with them, not just recently, but also back in geometry. Okay, so these other 3 trig functions, they're just reciprocals. Flip to find the recip. So flip sine, you'll get cosecant. Flip cosine, and you'll get secant. Flip tangent, and you'll get cotangent. And that's how Becker breaks it down.